Okay. All right, y'all. What's going on? The SAT math skill that I want us to work on today is imaginary numbers. Now, this seems to show up relatively consistently. I don't see a lot of these problems, but I see enough of them to make sure that I record a video over them so that you are prepared. Now, keep in mind that I'm going over an example here. But if you join my class that's referenced down here, patreon.com/MathSwap tutoring, my weekly SAT math practice class. We're gonna go a little bit more in depth than we do in this video, do a couple more examples, and go over a lot of other stuff too that's really important for you to know or to remember for the SAT. Because really at the end of the day, by the time you get to like 11th grade, if you've taken algebra 2 or you're in the process of taking algebra, you'll have basically covered what you need to know for the SAT. But it's a matter of remembering and being able to like really go in depth and apply that stuff. That's where the SAT, practicing for the SAT is becomes important. All right. So imagine that an imaginary number has the letter I in there. And I is almost kind of like a almost like a variable in a sense, but not quite. So I is just the number that results whenever you try to take the square root of -1. Okay. So that's all that I is. Now we'll go into depth in a little bit, but let's kind of like expand on this. Now, it's going to be important for us to kind of like understand, go a little bit further than this. If I is equal to the square root of -1, what is I squared? If we want I squared, that means square root of the other two. I squared must just be -1. So that square root goes away. What about I cubed? I cubed is just like multiplying I squared by another I. So multiply both sides by I. So that becomes -I. What about I to the fourth power? Okay. So you could either look at this as squaring I squared or even multiplying I cubed by another negative, another I. I to the fourth power is just 1. So this becomes important when you solve more detailed problems that involve imaginary numbers or what we'll call complex numbers. So I'm going to put and complex numbers. Complex, let me move this out of the way, numbers. Now, this is what I stands for. Now, the opposite of an imaginary number is a real number. And a real number is just a number that doesn't have I in there, really, to be honest. Now, complex numbers they take on this, essentially, they'll take on the form like this. A plus BI. So you have it has a real part and it has an imaginary part. Okay. So that's kind of generally the form they take. Now you have a concept of what you call, I'm going to label this complex conjugates. This is like a subtopic of complex and imaginary numbers. So complex conjugates are like so, A minus BI. So if you have A plus BI, its complex conjugate is A minus BI. What happens is if you add these together, you're left with only a real number because A and A will be 2A, positive BI and negative BI go to 0. If you subtract them, the result is imaginary number. So this minus this would be A minus A is 0. BI minus negative BI is just BI plus BI, which is 2BI. Okay. And so then also, if you multiply these together, that ends up becoming real as well. So, and it helps. Um, I'm gonna write this. You need to remember this. It helps sometimes to multiply a complex number by, sorry, my computer's moving a little slow, its conjugate. And an example of that is when we're trying to get a complex number out of a denominator. Okay. So keep that in mind. Keep that in mind. I don't know if we'll go over an example here, but I do kind of go a little bit more in depth like that in my class. Okay. All right. So let's actually go ahead and apply some of this that we've talked about in an example. And keep also in mind that SAT problems will start here and they might get a little bit more complicated because they may incorporate some other type of math, but it's really important that you get the foundational understanding of how imaginary numbers and complex numbers work. So simplify 8 plus 7i times 5 minus 3i. So mainly this concept is going to become important. If you understanding the i's is going to be important. All right, so first thing we want to do is expand these. And so I'm going to go ahead and do that here. Use FOIL. First, outer, inner, last. Multiply the first ones, the outer ones, then the inner ones, then the last ones. 8 times 5 is 40. 8 times negative 3i is going to be negative 24i. 7i times 5 is going to be positive 35i. And last, you have 7i times negative 3i is going to be negative 21i squared. Pay attention to that I squared. Remember, I squared is going to be negative 1. So we want to keep that in mind when we go to this next level. Let's combine like terms. This has no like terms, 40. Negative 24i plus 35i. So that's going to be 35i minus 24i. That's going to give us what, 11? So a positive 11i. You got negative 21i squared. I squared is negative 1. So negative 1 times negative 21 is a positive 21. And then finally, combine like terms again. 40 and 21 will give us 61 plus 11i. And that's our final answer here. All right. So the most important thing is understanding how I works. And then we just do algebra, basically. But you got to understand how imaginary numbers work, how the letter I works. Okay. Now, again, there are examples on the SAT where you may have to multiply a complex number that takes on the form a plus bi by its conjugate, as I've explained here on the screen. Keep that in mind that you'll multiply something by its conjugate to get rid of it in the denominator. Okay, so keep that in mind. Very important. But whatever you do to the bottom of a fraction, remember you have to do it to the top. Whatever you do to a numerator, you have to do to the denominator as well. Hopefully, this has been helpful. If you want me to record a video over another SAT math skill, feel free to comment. And remember to join my class at patreon.com/mathswaptutor. And I hope this has been helpful for you guys.